Well, since I've shown in my previous videos, I just can't leave well enough alone. I'm out here, was just thinking about stuff today, so I'm out here at my condenser. You can see I got a ICM fan speed controller on it. Just your 1.5 pole contactor, regular old run cap. But then you start coming down here and you might be like, what in God's name is going on? So like I said, I was just thinking about things today. I kind of did this little drawing right here. So basically what I did was how this unit was is obviously they were running the low pressure switch and the high pressure switch all in series. You know, it's what they normally do in residential units. So I was like, you know what? Just because I like messing around, I was like, let's see if we can do something about that, and you know, see if I can. Basically, I built myself an alarm right here, so I know which pressure switch, if it were to ever go out, is the problem. So what I have here is just a simple board here, and it is it's a, let me see, you can see the coil is 12 volts DC. So you know, normally all this stuff's AC. So see these little cubes right here, these are rectifiers. So it comes in 24 volts AC on this wire, and then this other opposite corner is your common. Then you have down here is DC plus, and that one is DC minus. So 24 volts AC, 24 volts AC common, DC plus, DC minus. So I send the DC up into here, and I probably need to fix that a little bit better, but that's okay. So that'll activate the coil. That'll in turn send 24 volts out. And then I'm also using this right here. So I was able to break the contactor coil with this relay right here. I have the high pressure switch is the coil, and the low pressure switch is the contacts. And yes, I have a big old mess, and yeah. So anyways, you can see here 24 comes in, goes through the pressure switch to the rectifier, comes out 24 volts DC, powers the coil on that board. 24 volts then continues, goes to the common terminal of the contacts, comes out. This is the high pressure switch side, obviously. Comes out on the normally closed, powers up the relay coil. Right? So if the high pressure switch were to ever break, the rectifier would lose the 24 volts AC. I'd lose my 24 volts DC. I would lose this coil too. So contactor coil would cease to operate because this coil would no longer allow power to pass. Same thing on the low pressure switch side. Comes in, goes through the low pressure switch. Sorry, the camera wasn't focusing. Goes to the rectifier. I get my 24 AC, powers the board coil. I have 24 coming down into common, coming out of common into the normal. Sorry, I have it drawn as normally closed, but disregard that. Normally open. So it would come out of the normally open, come down to the common terminal on the relay, go to the normally open, and that would go to the contactor coil. So I'm going to get this puppy fired up, and I'll show you that it worked. There we go. As you can see, I have my lights right here. So this is going to be my high pressure switch side. that's going to be my low pressure switch side. So if I ever am experiencing an issue and I see one of these lights not illuminated, well, that automatically is going to tell me that my low pressure switch or my high pressure switch is the issue. And like I said, I have an ICM fan speed controller, which is just purring along right there. Yep, I probably do a lot more than I need to, but I don't know. I love this trade. I love messing around. So I basically did all this work just to have a visual for an alarm if I have a high pressure switch or low pressure switch trip. Again, I used just a standard 24 volt coil relay. These two boxes, I apologize, you know, there's freaking wires everywhere and it is a bit of a mess, but these two boxes right here are rectifiers. 24 AC in, 24 DC out. That powers up down here. So this board, you can see on the coil, it's a 12 volt DC coil, but what this board does, you can either put 12 volts in on that middle terminal where it's marked 12, or you can put 24 in and then it just steps the voltage down to 12 volts. 0 would be like your minus. So 12 or 24 would be your plus and 0 is your minus. Again, the whole point of what I just did was all just so I could have that say, hey, you got a low pressure switch issue or a high pressure switch issue. But I don't know, I just like messing around, which I'm sure you guys can tell from some of my videos. Happy HVACing.